All right, welcome to day 6. Today we're talking about Midsegment theorem, points of in the triangle that meet at the same point. We call those points of concurrency, and then also we're going to talk about the unknown angles, so angles inside and outside of polygons, and that will wrap up today. Remember, at the end of the day, make sure you finish this worksheet, and if you're working on your retake, make sure you work on this for homework tonight. All right, so number 1, triangles. So the midsegment theorem of triangle is kind of like the side splitter theorem, where we had a line cut parallel, except this time these 2 points here, D and E, are going to be the midpoints of our triangle. Okay. Stuff's going on. All right. So that is what's going to be happening in terms of triangle here. All right, let's just make sure this is working. So these 2 points, D and E here, those 2 points have to be the midpoint. So either you're going to see saying something about the fact that these are the midpoints, or it'll just mark these segments like DC and AD and CE and EB congruent. Now, once you know that this is a midsegment, because it connects the midpoints, then we know 2 things. We know that the midsegment is parallel to that third side here, and that it's half the length of it, okay? The other thing we know is that the area of this small triangle up top, okay, DEC, is 1/4 the area of the big triangle, okay? So remember, the area is 1/4. And that is essentially because if we were to figure out where the midpoint of AB was, let's say it's there, and we connected it, remember, we're going to get 4 of these small triangles. So the area of this triangle here or here or here is going to be exactly 1/4 the area. Also, remember, we talked about the fact that if we know that the scale factor is 1 to 2, then the areas is going to be 1 to 2 squared. Okay, so that's how we also know it's 1 to 4. All right, so let's look at some example questions that I've asked before in the recent exams. Number 89 here in the diagram below, we are told that these lines are mid-segments. So first of all, remember, this line is exactly half of this line. So EF is equal to DB and AD, okay? And then DE is half of AG. So these 2 pieces that are equal, because it's a mid-segment, we know it's a midpoint, these 3 lines are all equal. And then the same thing about line segment DF. It's exactly half of BC, so it's equal to these 2 parts split by the midpoint. Okay, so the perimeter of quadrilateral ADEF, so let's trace that. ADEF, that's right here. So that perimeter. Okay, is it the same as AB plus BC plus AC, the perimeter of the big triangle? That's no. Is it equal to 1/2 of AB? So here's 1/2 of AB, which is just this, and 1/2 of AC, which is this. That's a no. Okay, is it equal to 2 times AB, right? 2 times AB plus 2 times AC. That seems like it's a lot. That would be 4 of these half lines. That's also not true. It is going to be choice 3. And the reason we know this is because, remember, let's say that this is, for instance, 5. We know that EF is also going to be 5 because it's half of this whole line, so it's equal. So if this is 5 and 5, which is 10, then 5 plus 5 here is equal to that 10. And likewise, if this was, let's say, 6, we know this would be 6 and this is 6, so this whole side is 12, and 6 plus 6 here is 12. So we have 12 plus 10 is 22, 10 plus 12 is 22. That's why it's going to be true. Because this is half of that line, and we have these 2 half pieces together for that quadrilateral, that's why it's going to be choice 4. All right, going to the right here. So if we know that DE is a mid-segment, we know once again that these are midpoints. So this is going to cut equal to this and be parallel, okay? And this is going to cut equal to this. If DE is 7 and AD B is 10, BC is 13. Find the perimeter of triangle ABC. Remember, this piece is exactly half of this whole line, so that's going to be 14. And then the perimeter, remember, means add all sides, so it's just 10 plus 13 plus 14, and that's 37. And there's my answer. All right, the next question down below here, DEF, the vertices of DEF, are the midpoints of the sides of the triangle. So once again, once we know that this is a midpoint, we know that these are mid-segments, okay? So these are cut in half, and BD is equal to AD, which is equal to EF, AF is equal to FC, which is equal to DE, and then DF is equal to BE, which is equal to EC. So, key thing, we know that this triangle is equilateral all the way around. So if the perimeter of the triangle is 36, 36 divided by 3 is going to be 12. So what is the length of EF? So once we know that this side length is 12, because it's an equilateral triangle, perimeter is 36, we divide it by 3, then this across the way is just half of that, which is going to be 6. Okay, so key thing, we noticed midpoints, which led us to know that this is going to be a midsegment. Once it told us it was equilateral, we just needed to get the length of AB and then take half. Okay, the other one is going to be a midsegment, but this one is going to be in a trapezoid. Now, kind of like on the midsegment here, where this is in the middle, this line is also going to be in the middle. So the midsegment of a trapezoid, okay, the midsegment is equal to the average of the bases. That's supposed to say bases, but that does not. Okay, so you kind of think of it as the midsegment is equal to base 1 plus base 2 divided by 2. It's essentially a quick formula for you. So if we see number 440, it says that we have midpoints. X is the midpoint of RT, so these are equal, and V is the midpoint of SU. These are equal. So if RS is 30 and XV is 44, how do we figure out the length of TU? So if we just call this, for example, X, we can say 30 plus X divided by 2 is equal to 44. We can cross multiply or multiply both sides by 2. You get 30 plus X is equal to 88. And then we can subtract 30 to get our final answer. Now, you can also think about it with numbers and say to yourself, kind of like our leapfrog thing from before, how do you get from 30 to 44? We have to add 14. So we have to add the same amount to jump from the midsegment to the other base. So if you just add 44 and 14, you'll also get 58. But that is just another way to look at how to do this question. All right, on to the next page, points of concurrencies and triangles. So the key thing here with the concurrency points, okay, is going to be, sorry, I just need to be able to get my pen back here. Identifying what type of lines are drawn. So if we see that these lines cutting through the triangle are making right angles, okay, and we know that these lines are being marked equal, this is important, then we know that these are the perpendicular bisectors of the segments, and therefore this is going to be the circumcenter, okay? That's important, got to be perpendicular bisectors. Second one, if we see the angle markings, okay, indicating that these angles are all being cut in half, then we know that these are the angle bisectors and they form the incenter, okay? The medians, once again, kind of looks like the perpendicular bisectors, except there's no right angle. So just the median is the line from the opposite vertex that cuts the other base in half. So you'll notice that you get these two, the slash is going through the sides, but you'll be missing the 90-degree angle mark here. And so this is a median. And the last one is the altitude. You're going to notice you have the 90-degree angles down here but you don't have them intersecting and cutting this line in half. So altitudes, orthocenter, medians, metroid, we talked about that one, the metroid, okay, making the centroid, the abe in, all right, and then PBC, and then the AO. So however you want to remember this, those are kind of the ways that I remember them for myself, but if you have another way, that's awesome. Couple things, the incenter and centroid are always located inside the triangle, and the orthocenter and circumcenter can be either in, if it's an acute triangle, on when it's a right triangle, or outside the triangle when it's obtuse. Doesn't usually come up a lot anymore, but just something to keep in mind. Okay, so take a look at number 91. Let's answer some questions about points of concurrency. Now, the big one to be brought up here is with the centroid, okay? In the centroid, this top line here for the actual median is going to be twice as long as the line on the bottom part here. So this is the only other thing with a median that happens, is that the top part of the median is twice as big as the bottom part. And essentially then, the whole thing is in a ratio of 2 to 1. So the bottom part is like 1/3 of our line, and this top part would be 2/3 of the line. All right. So if we go look at number 91, I'm just going to scroll up so we can see what we wrote here. Triangle SRK below, we have the medians drawn. So that tells me that point M is the centroid. Okay, because medians, metroid, centroid. So that means also tells me that this line, right, SM, is twice as big compared to this. And this whole thing is in a ratio of 1 to 2. So this is 1/3 of the line, and this is 2/3 of the line. All right. So if we take a look, is 3 times MC equal to the whole line SC? And that would be true, okay? That would be true. Because this bottom part is 1/3 of the line, so 1/3 times 3 is 1, is the whole line. So this is true. Now, if we look at MC, is MC equal to 1/3 of SM? And no, this is 2 to 1. So this should be 1/2 times SM, so that's out. Is RM, this piece, equal to 2 times MC? Nope, it would be 2 times ML. So that's also out. And then is SM equal to KM? That is not correct unless those lines are already equal. So that's only going to be true if it's an equilateral triangle. All right, right next door, 92, we have angle bisectors drawn. So we're cutting all these angles in half here. All right. If angle BAC, so the whole angle here, all right, is 50 degrees, find angle AXC. That's AXC. That's this angle right here we want to find. All right, now, if this is 50 degrees, ooh, there's another thing we missed. We didn't read the question fully. In the diagram below of isosceles triangle ABC, where AB and CB are equal. That's important. So this side of the triangle is equal to this side, which means these two base angles in the corner are also equal. So I have angles of getting cut in half. They were 50, of 25 and 25 here. Now, if you notice, we have a triangle being formed here. And this is going to help me out because I know that this entire angle up here, the whole thing, is going to add to 180 with the 25s. And then we just want to take for AXC, that's the angle we're looking for, is this whole angle right there. So we're just going to do 180 minus the 50, and that's 130. And that is the measure of angle AXC. I thought it was this one for a minute, but it's the whole thing. And so it's just 130 degrees. So if you see angle bisectors, make sure you label your diagram with them for yourself. Okay, this question popped up a couple years ago, and it was one of the ones that a lot of the students struggled with. So number 94, In the diagram below, triangle ABC has vertices which are given. What is the slope of the altitude from A drawn to BC? Now remember, if A, you draw the altitude to BC, it's going to make a perpendicular line. So what is the slope of the line that is perpendicular to BC? That's all they want to know. Remember that perpendicular lines have negative reciprocal slopes. So this is all we need to answer this question. So if we look at the slope of the line from B to C, we can actually just count using the rise and the run. We're going right 1, 2, 3, 4, 5. That's positive 5 since we're moving right, and positive 2 since we're going left. So the slope of BC is going to be 2/5. That means the slope of any line perpendicular is the negative reciprocal of this. So make it negative and flip your fraction. Whoops, not 2/5, that's not flipped. Negative 5/2. Okay, and that should be our answer. So as long as you knew you had to find the slope and do the opposite reciprocal, this question was very easy. But it tripped a lot of people up because they didn't understand what that meant with altitude. All right, 95. We want to know what type of triangle this is. So all we basically want to do is kind of draw it for ourselves. We can either use slope or we can use distances here. Okay, so RST is given. R is -2, -3. S is 8, 2. And T is 4, 5. Now, if this were given on the exam, remember that you have a detachable graphing paper at the end of your test. So you can always fold that into like 4 parts, like fold it in half again, and then you can use those graphs anytime you want there. All right. I'm just going to go ahead and draw these straight lines. You can go ahead and do that for yourself. All right. And then we want to know what type of triangle this is. So a couple things. If we look at the lines being drawn, we can kind of tell that this line is definitely not the same length as these ones. So we can rule out equiangular because that's the same thing as equilateral. Those are the exact same thing. Either if all the angles are equal, all the sides have to be equal. Now, acute, right, and obtuse, what we can do is we can check Pythagorean theorem if you'd like. All right? So, or we could check the slopes, one of the other option. If we use Pythagorean theorem, remember that if a squared is equal or plus b squared is equal to c squared, it's going to be right. If the a squared side is bigger than the c squared side, it's going to be acute. And if the a squared plus b squared side is smaller than, so if the c squared side wins, it is going to be obtuse. So you can use that to help you figure these ones out. Now, once again, we could just draw our lines over to get the rise over run. We can count 2, 4, 6, 8, 10. So going from -2 to 8 is 10. That's positive because we're moving to the right. And then we're going up 1, 2, 3, 4, 5. Positive again. We can also move up here, which is +3. And then we can move left 4. That's -4. And then we're going to go from R, we're going to go up. So 3, 4, 5, 6, 7, 8. And then we're going to go over to the right. Looks like 6. Okay. Now, if we want to, we can easily look at the slopes of our lines real quick. So the slope of RT, all right, is up 8 and over 6 to the right, which is going to be 4/3. We can also see the slope of TS is going to be up 3 and over 4 to the left, which is -3/4. And immediately, what should catch your attention is that these lines are indeed opposite reciprocals. And so that means this angle is 90 degrees and it has to be choice number 1. Now, if you didn't want to do that, what you could do is use Pythagorean theorem, which we talked about. As soon as I notice that these are 8 and 6, I'm going to do 8 squared plus 6 squared is equal to c squared. This is going to give us 100. And then the square root of that is going to give us 10. So I know what this length is right here. I also have 3 and 4. So it's 3 squared plus, I was going to say b squared for a second there, 4 squared is equal to c squared. This is 25. And we should know, hopefully there are 3, 4, 5 right triangles, but this is now 5. And then the last one is 10 and 5, so 10 squared plus 5 squared is equal to c squared. This is 100 plus 25, so 125. And I'm going to stop right here. I don't have to go any further. We'll leave it just like this. So if I check my Pythagorean theorem, a squared plus b squared equals c squared. And this is for the big triangle here. A is 10, b is 5. Those are the two legs right there. We're like squared plus leg squared is equal to the square root of the hypotenuse squared. And hopefully by this point from our circles we know we square root, we just get the number back inside. And then this is 125. And so since these two things are equal, that is a terrible looking 5. It's more like a square root with a little thing down there. That this means this is going to be a right triangle, since a squared plus b squared is equal to c squared. So that was just another option for you to answer this question. Okay? So if it's asking you what type of triangle, you can use slopes, you can use Pythagorean theorem, and then you'll just check. All right. Last one here, remember the unknown angles in a right triangle. So remember, we just need to know a few things. Number one, remember that the sum of the exterior angles is always 360. And then we said before that if the number of sides was n, the number of triangles is n minus 2, and therefore all the interior angles of any figure are always 180 degrees times the number of triangles, which is n minus 2. All right, and then we just divide by n to get the measure of each angle as long as it's a regular shape. Okay. The other thing we talked about is that, remember, in the exterior angle theorem, as we have the exterior angle drawn to a triangle, this exterior angle is equal to the sum of the two interior angles. So the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3. All right, so let's take a look at number 1. Julian plans to make a drawing of ABC where the measures of A can range from 50 to 60, B can range from 90 to 100. Given these conditions, what is the correct range of possible measures for angle C? Well, first of all, it's a triangle. So we know that all the interior angles are always equal to 180. When it's asking you for a range question, you always want to think about what if you went from the largest to the smallest amounts. So if we made angles A and angle C, okay, as large as they could be, what would be left for the measures of angle, or A and B as large as they can be, what would be left for angle C? And then if we made A and B as small as they can be, what would angle C be? So if we made these two angles, here's A and here's B, if we made them as big as possible, okay, we made them as large or as small, as big as possible, what's left for the third angle here, okay? So as we may increase these sizes, that's going to decrease what C is. So really what you want to think about, I'm going to not draw a triangle, it gets a little confusing, okay, is we're going to think about the smallest numbers together, okay, and then we're going to think about the biggest numbers together. And what would that range be? So if we compared 50 and 90, that's equal to 140. And so if we take 180 and subtract away the 140, that leaves 40 degrees left over. And on the other side of it, if I add the biggest degree measures together, 60 plus 100 is 160. We take all that away from 180. That leaves me with 20. So somewhere in between using the smallest and the largest numbers, this angle, okay, angle C, has to be somewhere stuck in between these two amounts. So it has to be, and I guess we should go a little bit bigger, switch this around. The most it can be is 20, and the highest it can be is that 40. Okay, it's stuck in here. And actually, you know what? It was right the first time. All right. Okay, and if you like, 20 to 40 is one of our answers. All right, next one. Regular octagon sitting in a brick wall. What is the measure of angle x? This is an exterior angle, so we know that angle 360, if we divide it by the number of angles here, or the number of sides, 1, 2, 3, 4, 5, 6, 7, 8, it's an octagon. So 360, and just divide that by 8, and this is going to be 45 degrees. Okay? If we were wondering about the number of angles inside, we could have done 180 times 8 minus 2 over 8. This would give us an interior angle. All right, once again, we have a birdhouse building in the shape of a regular pentagon. Remember, regular just means that all sides and angles are congruent, are shown in the diagram. We extended AE over F. What is the measure of angle DEF? So once again, this is an exterior angle, and it's a regular pentagon. So there's 360 divided by 5 is going to be my answer, and that is going to be 72 degrees. If it was interior, remember we could just do 180 times, times, and then it's 5 minus 2 for the sum, and then divided by 5 for the final answer of the interior. All right. Number 4, the sum of the interior angles is 720. How many sides does it have? Now, it's only 4 choices, so we could just take this and plug in 8, 6, 5, and 4 and see which one gives us 720. The other option is to solve for n. So we could just divide by 180, and we'll get n minus 2 is equal to, we're going to divide out, and this is 4, and then we add 2 to both sides to get n is equal to 6. Okay? But if you just plugged in 8 and then 6 and 5 and 4, eventually you'll see which one is equal to 720. And that is it for today. Okay? So there'll be a couple questions for you guys to take a look at in Schoology today. Please make sure you answer those. But otherwise, keep working on that practice test and or working on the sheet and on those questions. We'll see you tomorrow, guys. Have a great day.